Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we have a current that is produced in a wire that has some resistivity, and we want to know the magnitude of the magnetic field at the point P due to the current that is passing through the wire in different times. So for A, B, and C, we want to know for A, we want to know for T equals 20 milliseconds, for B, T equals 40 milliseconds, and for C, we want to know for 60 milliseconds. And from the figure, it is not so clear in this sketch, but if you have the book, you can follow more closely. The figure shows that when we have t equals 20 seconds, we have the current equals 4. So for this case, E equals 4 amperes. For this case, E equals 8 amperes. And in this case, E equals 10 amperes. And then we can find the magnetic field. B is just mu0 I over 2 pi r. And this case is 0.089 Tesla, microtesla. And in this case, B equals mu0, again the same formula, 2 pi r. And substitute the values, this is 0.18 Tesla. And in this case, the same formula, u0 I divided by 2 pi r. And in this case is 0.220 Tesla. Now for part D, E, and F, we want to know the magnitude of the magnetic field at the point P due to the displacement current. So for this, we have that the displacement current is given by the variation of the electric field, epsilon 0 A d dt. And we have in this wire that the electric field is given by rho I divided by A. So we get that the displacement current is epsilon 0 rho di dt, where we have from the figure that di dt is equal to 200 amperes per second. So we have the displacement current, the magnetic field due to the displacement current now at the same point, 20, 40, and 60 seconds. So let's do this. So this is for D, E, and F. This is 20 milliseconds. This is 40 milliseconds. 60 milliseconds. And this gives Bi equals mu0 E now displacement divided by 2 pi r. And this is 6.4 times 10 to the minus 22 Tesla. Here, the same formula. And because the current induced current is the same, we have the same value, 6.4 times 10 to the minus 2 Tesla. And for this case, this is outside the current. So the current is already shut off. So there is no induced current, only the other current. So we have that Bi is equal to 0. Now, for part G and H, we want to know at the point P and 20 seconds, what is the direction of the magnetic field from the current and from the induced current. So for by the right hand rule, we have the direction of BI is out of the page. And at the same time, BID is also for H is out of the page. So we have the current moving here, and then the magnetic field is coming straight out of the page.